Hey everyone, and welcome. If you're deep in your CMA Part 1 prep, you know there are some topics that just look intimidating. Well, today we're going to tackle one of those head-on, learning curve analysis. Now, I know, the name sounds all mathy and complicated, but trust me on this. The idea behind it is super intuitive. It's really just about getting better and faster with practice. By the time we're done here, you'll see exactly how to make this topic a source of easy points on your exam. So here's our roadmap. First, we'll cover what the learning curve even is. Then we'll jump into the most important part, the doubling rule that powers all the calculations. After that, and this is crucial, I'm going to show you the #1 trap examiners love to set with these questions so you can just walk right around it. Then we'll talk about when the learning eventually stops, and finally, why this all matters way beyond the exam. Sound good? Let's dive in. All right, so first things first, what in the world is the learning curve? Before we get into any formulas or charts, let's ground this in something we've all probably done. I want you to think about the last time you had to assemble some of that flat pack furniture. You know what I'm talking about. The first time is a journey, right? You're staring at these weird diagrams, fiddling with screws. You probably put a shelf in upside down. It takes forever. But what if you had to build a second, identical one right after? You'd fly through it. You already know the tricks. That feeling of getting faster and more efficient, that's the learning curve. Simple as that. Okay, so now let's put our management accountant hats on. We take that very simple idea and we turn it into a predictable mathematical model. And here's the key sentence you need to remember. As your total production doubles, the average time it takes to make each unit goes down by a consistent percentage. This isn't just some abstract theory, you guys. For a company launching a new product, this is an absolutely essential tool for forecasting how many labor hours they'll need and what their costs are going to look like. So let's really zero in on that doubling idea. This is the engine. This is the core mechanic that will drive every single learning curve question you see on the CMA exam. If you get this, you're halfway there. This right here, this is the golden rule. Burn this sentence into your brain. For the exam, we use what's called the cumulative average time model. And all it says is that every single time your total output doubles, so you go from making 1 unit to 2, then from 2 units to 4, then 4 to 8, and so on, you take the average time per unit and just multiply it by the learning percentage. Let's make this real with some numbers. Okay, check out this table. Let's walk through it. Row 1, nice and easy. The very first unit takes 100 hours. Total time is, well, 100 hours. Now, we double our production to 2 units. What do? We take the old average, 100 hours, and we hit it with our 80% learning rate. That gives us a new cumulative average of 80 hours per unit. And the total time? Just 2 units times that 80-hour average, which is 160 hours. Now let's double it again to 4 units. We take the last average, the 80 hours, multiply that by 80%, and we get a new average of 64 hours. Total time is 4 units times 64, or 256. See the pattern? Every time we double, that average time per unit drops. Okay, everybody, I need you to lean in for this next part because this is huge. This is the single biggest trap that shows up in learning curve questions, and I see so many students lose easy points right here. But you're not going to because it's actually super simple to avoid once you see it. See, the exam writers know it's too easy to just ask for the total time for 4 units. They get sneaky. They'll ask something just like this. What was the time it took to make only the 3rd and 4th units? Now, your first instinct might be to just grab that 64-hour average for 4 units and multiply by 2. And that's exactly what they want you to do. And it's exactly wrong. So, how do we get the right answer? Here's the right way. It's a simple 3-step process, and it's all about working with the totals. Step 1, find the total time for the big number, all 4 units. We already know that's 256 hours. Step 2, find the total time for the smaller number, the first 2 units. We know that's 160 hours. Step 3, the final move, you just subtract the small total from the big total. 256 minus 160 gives us 96 hours. That's the actual time it took for just units 3 and 4. So let's make this our unbreakable rule. Write this down. For any question that asks for the time of a specific block of units, you always calculate the total hours first, and then you subtract to find the incremental time. Make that your automatic muscle memory, and you will literally never fall for this trap again. Now, a logical question you might have is, does this just go on forever? I mean, do people get so good that it eventually takes them 0 seconds to make something? Well, obviously not, right? At some point, the improvements have to level off. And that point where things level off is what we call the steady state. It's basically when the learning curve flattens out and the time per unit pretty much becomes constant.
This happens for a couple of reasons. Maybe the process becomes automated and a machine is doing the work now, and machines don't really learn. Or it could just be that the human workers have hit their physical peak of efficiency. You can only move so fast. And knowing this is so important for budgeting, because you can't tell your boss that labor costs are going to keep dropping by 20% forever. You have to be realistic.
All right, we're at our final section. Let's talk about the big so what. Why should you care about this stuff beyond just checking a box on the CMA exam? Well, because in the real world, this is a seriously powerful strategic tool. This one little concept has a huge ripple effect. Think about pricing. If you know your labor costs are going to drop significantly on a large order, you can give a potential customer a much more aggressive price right out of the gate and win that business. What about budgeting? Oh, this is a big one. It helps you create razor-sharp labor budgets and prevents managers from building in a bunch of slack based on how slow things were at the very beginning. And for capital budgeting, well, when you see your team has hit that steady state, that's your data-driven proof to say, hey, our people are maxed out. It's time to invest in that new machine to get us to the next level of productivity. So to wrap it all up, let's put it back on you. Quick challenge. Based on everything we just covered, how would you figure out the time for the next batch of 4 units? So units 5 through 8. Pause and think about it for a second. You got it, right? You'd calculate the total hours for all 8 units, then you'd calculate the total hours for the first 4 units, and you just subtract the 2. That difference is your answer. If you can map that out in your head, then you've officially got this. You have the tools. Go practice a few problems and you will absolutely crush this on exam day. You've got this.